Welcome to second lead code problem. Add two numbers. It comes under difficulty medium. Let's understand question. You are given to non-empty linked list. So we have linked list 1 and linked list 2 here. This is first linked list. This is second linked list. Representing two non-negative integers. So these two linked lists will represent non-negative integers. It means that the numbers in the linked list greater than or equal to 0. It might be greater than 0 or equal to 0. The numbers in the linked list. The digits are stored in reverse order. So let's understand. Actually, the number 342465, which are actual numbers, but in the linked list, they gave you in reverse order. So 243 in reverse order, 465, 564 in reverse order. Let's understand why they gave you in reverse order. So this is natural sum where we add left to right in mathematics, right? So the first place is unit place, next tens and hundreds. So we add from left to right here. So the sum is 7, the sum is 10, the carry will be carried to next sum. So this is natural way we add in the mathematics. So let's understand what will be the difficulty if you add the same way in the linked list. So I kept these numbers as it is in the linked list 342 465. So in the linked list the problem is to come this node first, you have to know this address. This address will be in the previous node and this node address will be in the previous node. So first you have to traverse from left to right, then you have to add from right to left. So to avoid this complexity, they gave you in reverse order. So here I reversed these numbers and kept in the linked list. They gave you in reverse order in the problem, right? Problem statement. So here the unit place in natural sum, that will be come to the first position or first node in the linked list, and tens place in the middle and hundred place comes to last. So here we can we can do that natural sum from right to left. So to avoid that complexity they gave you in reverse order. So here the sum will be 7, sum will be 10, and 1 will be carried to the next addition. So the sum will be 8. So this is the reason they gave you in reverse order, just to avoid the complexity. The next statement is the digits are stored in reverse order and each of their nodes contains single digit. So the digits in the linked list which are single digit only, you don't see any two-digit number in the node. Add the two numbers and return sum as a linked list. So here we adding these two linked list 7, 10, carry will be carried to the next addition and sum will be the 8. So we just written this linked list. We don't need to reverse. You may assume these two numbers don't contain any leading 0 except 0 itself. It means that, see, any linked list, you given the number might be 0, it is valid because except number 0 itself. For example, the number 0, 1, 2, 3, it is not valid because the number leading with the 0 here. See this, you may assume two numbers not contain any leading 0. If it is contains leading 0, it is not valid number. For example, 0, 0, 0, it is also not valid because the number 0 itself valid, because in this number apart from 0 we have two more numbers which are 0. That is why it is not valid number. 1, 2, 3, this number is valid because there is no leading 0, right? So this number is valid. So let's understand. Here they mentioned three constraints. The first constraint is number of nodes in each linked list, the range will be 1 to 100. So in the linked list they gave you nodes, right? So these nodes number will be up to 100. It won't be more than that. So this nodes will be 1 to 100 only, because this range is enough to cover all real-time scenarios. Uh, Above this range, it will add some complexity to the problem. So that is why they mention this range. So the node value, the value in the node 243, right? So this will be between the range 0 to 9. Means that there is no double digit number. This is one more constraint, and last constraint is it is guaranteed that the list represent a number that doesn't have any leading zeros. As I explained you here, if number contains leading zero, that number is not valid. So let's understand its logic. So here I created two linked lists L1, L2. I'm passing these two linked lists to add two numbers method. In this method, we iterate each node in the linked list and we add them. Finally, we return this result linked list from this method. So this is goal of this method. So here, first line, I created dummy head. Let me explain you why I created dummy head. See here, first I created one node. Its name is dummy head. So usually we call first node in the linker list as head. So here I'm assigning one value to its dummy head. Its value is the 0. First created dummy head, and one its name is dummy head, and one pointer to this dummy node, its name is result. See, result, this result is pointer. This pointer will move till last. For example, here after adding these two linked list, I got, for example, 5 nodes right here. So this pointer, after computation, at the end of the computation, this result will come to here. So this is movable pointer. That is what I'm trying to tell you here. Here, why I'm creating dummy head is, if you don't create dummy head, we need to write extra logic to create first node separately. See, now I created dummy head. So it means that linked list is created. Now the result from addition of two linked list, we can directly add to the this dummy node. If you don't create this dummy node, you have to check first, like is head equal to null. If head equal to null means still linked list is not created, because first node we call in the linked list as a head node. If head is null, it means that still there is no linked list is created. If head equal to null, create linked list and assign new node to this head. So this conditions we have to check. If else, if head is already there, directly assign that value to the head. So these conditions we have to write if you don't create head node first. So to avoid this conditional checks, I created dummy head here. So the result come from this addition, directly we can add to this node. So at the end of the result, we can skip this first node and we can return remaining. So the next variable is int carry equal to 0. This variable initially assigned to 0 because the addition from this 9 the result is 18. So initially there will be no carry, right? So that is why it is initialized to 0. But the important point is it should be declared outside of this while loop, because at the last nodes here the sum is 19, 1 will be carry here. So here the sum is here 1, it is 10, right? So while loop have control till here only. So here carries after this while loop iterations. So to maintain this value, we declare this carry outside of this while loop. After leftover carry, we have to create one new node. We assign this value to result node. That is why we have to write this carry outside of this while loop. So here I created two variables, int xy. To iterate the value from L1 will store in the x. To iterate value from list 2 will store in the value y. Till iterating not equal to null. If list 1 equal to null means there is no node in the linked list. So iterate till they are not equal to null. Here this is linked list 1, pointer L1 points to this linked list 1, this L2 points to this linked list. Here I'm first iterating if L1 equal to null, if L1 not equal to null. So get that value. Here L1 is not equal to null, right? So get that value by using L1 dot value. If I call L1 dot value, I will get this value 9 and move this pointer L1, this pointer to the next node for next iteration. So here I will move this pointer L1 to the next node. Now go to second if condition. Here in second if condition, L2 is not equal to null. L2 is not equal to null. Then get its value. L2 dot value equal to 9. So the value from next node is 9 and move this pointer L2 to the next node. So now L2 points to the next node. It will get that value in the next iteration. Now we have values 9, 9, 0, carry is 0, right? 9, 9, 0, the total sum is 18. So here 18, to get this last digit from 18, so you have to do modulus operator which will return remainder. In programming, to get the quotient we have to use division operator. To get the last digit as a reminder, we have to use modulus operator. So that is why I'm using these two operations here. This is the carry, quotient is carry, reminder, which is the number we have to store in the linked list. So from this two operations, I got 8. So 8 I have to add it in the result node. See this here, this at this step. So I created new node, new list node with the new result 8. And the carry 1, it will forward to the next sum. 1 will come here because carry is 1, right? So after creating new node 8, we have to move this result pointer to this node. See this here at this line. So we have to move this pointer result to next node. Result dot next. Now result points to this new node. Again while loop start iterating remaining nodes. So in the next iteration, now L1 not equal to null. So get its value L1 dot value. Here this value is 9 and move that pointer L1 to the next node. So now L1 I'm moving to the next node. Its pointer. Okay. So after that we have L2 not equal to null. Get that value and move pointer to the next node. Here value 9, get that value and move pointer L2 to the next node. Now L2 points to here. So sum will be 9 plus 9 and carry. So sum 19. So from 19, from division we get the carry 1. From modulus operator we get the value 9 which we store in the linked list by creating new node, list node and sum, and move this result pointer to the next node. Now result points to next node, and one carry will be forwarded to next sum. Again while loop start iterating, get first value and get second node value, and move these two pointers L1 L2 pointers to next nodes, L1 and L2 points to null because there is no value. When it is null, we treat it as a 0. So now the sum is 19. So 19 of 19 division of 10. So the value is 9 and 1 will be carry forwarded. So again we move this result pointer to the next node. So created new node here and move that pointer result to the next node. Result. In the next sum, 9 plus 9, 10. So we create again new node with the 0 and move pointer to the next node. So now result is points to this node. Yeah. So we completion of iterating all the nodes in the linked list, both linked list. So now while loop comes to here, while L1 not equal to null, L2 not equal to null. Actually, these two nodes are completed. So the condition failed here, right? Because L1 also null, L2 also null. So the condition will fail, and after while loop, the code will be executed. So after while loop, we check carry is available or not. So carry 1 is available, right? So we create a new node with the carry, and after we create this new node, we return this entire result apart from dummy head, because this is not actual result, right? That is why we are returning dummy head dot next. So the result from after next of dummy head will be returned. Code which I explain you, I'm executing in the lead code. Let's check this submission. So it got executed successfully. When you click on analyze complexity, you will see time complexity big O of n. Let's understand its time complexity. The complexity is big O of n because we are using only one while loop to iterate these two linked lists in parallel. Because if we traverse them both linked list independently, the time complexity will be big O of m plus n. But we are traversing these two linked lists in parallel, so the time complexity is big O of n linear time complexity. But to write in more precise way, the time complexity for this solution is big of max m comma n. See here, if both linked list have same sizes, for example, uh, linked list 1 size is 4, linked list 2 size is 4. So here is n representation of either size of the linked list. So this is correct way of writing. But if we have different sizes in linked list, for example, linked list 1 have 5 nodes, linked list 2 has 4 nodes. We have to iterate till longer list completion, right? That is why we have to tell max of 5 comma 4. The max between 5 comma 4 is 5. So it will take 5 iterations to complete this L1 L2 addition. So the more precision way of writing time complexity for this solution is big O of max m comma n. This is the time complexity for this. Here m is length of the linked list 1, n is length of the linked list 2. See here max is just a normal function. It will decide what is the bigger in lengths m or n.